NENOMATICA, where mathematics meets YouTube excellence. Welcome to our mathematics video. Today we're going to learn about multiplying polynomials using the distributive property. When multiplying two polynomials, we can use the distributive property, which is also known as the distributive property of multiplication over addition. According to the distributive property of multiplication, when multiplying two polynomials, we need to multiply each term in the first polynomial by each term in the second polynomial, and then add the results. Let's look at an example from our material. Let's solve this step by step. First, let's identify what we're multiplying. We have 4x, which is our first factor, and we're multiplying it by the expression 2y minus 3, which is our second factor. To apply the distributive property, we need to multiply 4x by each term inside the parentheses. First, we multiply 4x by 2y, which gives us 8xy. Then, we multiply 4x by negative 3, which gives us negative 12x. 3, which gives us negative 12x. Now, let's simplify our result. 8xy plus negative 12x can be written as 8xy minus 12x, which is our final answer. Let's see another example from our material. In this example, we have x over 4 multiplied by the expression a plus b squared. We'll apply the distributive property again, but this time our first factor is a fraction. Let's apply the distributive property. First, we multiply x over 4 by a, which gives us ax over 4. Then, we multiply x over 4 by b squared, which gives us b squared x over 4. This is our final result. We have ax over 4 plus b squared x over 4. We could factor out 1 over 4 if needed, but the expression is already simplified, as is. Let's summarize what we've learned about. Welcome to this mathematics video, where we'll learn about the distributive property and how to multiply algebraic expressions. The distributive property is a fundamental concept in algebra that allows us to simplify expressions by distributing a factor across terms in parentheses. Let's start with our first example. We need to find the product of 4 and the sum of x plus y, and express it in the simplest form. To solve this, we'll use the distributive property, which states that when we multiply a term by a sum in parentheses, we distribute the multiplication to each term inside the parentheses. First, we identify the terms. 4 is our factor outside the parentheses, and x plus y is our expression inside the parentheses. Now, applying the distributive property, we multiply 4 by each term inside the parentheses. 4 times x gives us 4x, and 4 times y gives us 4y. Simplifying further, we get our final answer, 4x plus 4y. Let's move on to our second example, which is slightly more complex. Our second example asks us to multiply 3x and the expression y minus c. Again, we'll use the distributive property. Remember the rule. When multiplying a term by an expression in parentheses, we distribute the term to each part inside the parentheses. In this case, 3x is our outer factor, and y minus c is our expression in parentheses. Note that the same property applies even when the expression inside parentheses has subtraction. Applying the distributive property, we multiply 3x by each term inside the parentheses. 3x times y gives us 3xy, and 3x times negative z gives us negative 3xc. Simplifying, we get 3xy minus 3xc. Now, let's look at our third example, which is a bit more challenging. In our third example, we need to multiply the expression 2x plus 4y by x. This example is slightly different because the variable x is outside the parentheses on the right side, but the distributive property still applies. We can rewrite this as x times the expression 2x plus 4y. Now that we have it in the standard form for applying the distributive property, we can distribute x to each term inside the parentheses. X times 2x gives us 2x squared, and x times 4y gives us 4xy. So our answer is 2x squared plus 4xy. The distributive property tells us that we need to multiply each term in the first parenthesis by each term in the second parenthesis. Let's apply this rule step by step. Now, let's simplify our expression by multiplying the terms. So we have a squared plus ac plus b, a plus bc. And since ba is the same as ab, we can write our final answer as a squared plus ac plus ba plus bc. Let's move on to our next example. In this example, we have a monomial, 4x cubed, multiplied by a trinomial, x plus y plus 1. Let's apply the distributive property again, but this time we'll distribute the 4x cubed to each term in the parentheses. Now, let's multiply each term. This gives us 4x to the fourth power plus 4x cubed, y plus 4x cubed. Let's continue with our third example. In this third example, we have a binomial multiplied by another binomial. We have a binomial multiplied by another binomial. We'll apply the distributive property as we did in our first example. Now, let's multiply each pair of terms. So we get ax plus ay plus bx plus by. Let's look at our final example, which is a bit more complex. This example involves multiplying two binomials, but with negative terms and higher powers. Let's apply the distributive property, being careful with the negative signs. Let's multiply each pair of terms, keeping track of the signs carefully. This gives us 6x cubed minus 8x squared minus 9x squared plus 12x. Now we can combine like terms. The x squared terms are negative 8x squared and negative 9x squared, which gives us negative 17x squared. So our final answer is 6x cubed minus 17x squared plus 12x. To summarize, the distributive property allows us to multiply expressions by distributing 18x squared plus 12x. We have the expression 4x squared times the expression x squared minus 6x plus 2. To multiply these expressions, we'll use the distributive property. This fundamental rule tells us that when we multiply a term by an expression in parentheses, we need to multiply that term by each individual term inside the parentheses. So we take our term 4x squared and multiply it by each term inside the parentheses x squared, negative 6x, and positive 2. First, 4x squared times x squared equals 4x to the fourth power. Next, 4x squared times negative 6x equals negative 24x cubed. Finally, 4x squared times positive 2 equals positive 8x squared. So our final answer is 4x to the fourth power minus 24x cubed plus 8x squared. This matches the solution shown in our example. The distributive property allows us to multiply each term in the first expression by each term in the second expression. Let's move on to our second example. Here we have the product of two binomials, the expression 4x squared minus x times the expression 6 minus 3x. This time, we need to use the distributive property twice. We'll multiply each term in the first binomial by each term in the second binomial. When multiplying binomials, we can use the FOIL method, which is a mnemonic for first terms, outer terms, inner terms, and last terms. Let's apply this method step by step. First terms, 4x squared times 6 equals 24x squared. Outer terms, 4x squared times negative 3x equals negative 12x cubed. Inner terms, negative x times 6 equals negative 6x. Last terms, negative x times negative 3x equals positive 3x squared. Now we combine like terms. We have negative 12x cubed, and for the x squared terms, we have 24x squared plus 3x squared, which gives us 27x squared. And finally, we have negative 6x. Wait, there seems to be a discrepancy with the solution shown in our example. Let me double check the calculations. In the provided image, the solution is written as negative 12x cubed plus 27x squared minus 6x. This matches our calculation, but there was an error in the intermediate step of the original solution. The correct solution is negative 12x cubed plus 27x squared minus 6x. Let's look at our third example. We have the expression 2x plus 3 times the expression x squared minus x plus 1. For this example, we'll again use the distributive property. We need to multiply each term in the first expression by each term in the second expression. First, we'll multiply 2x by each term in the second expression. 2x times x squared equals 2x cubed. 2x times negative x equals negative 2x squared. 2x times 1 equals 2x. Next, we'll multiply 3 by each term in the second expression. 3 times x squared equals 3x squared. 3 times negative x equals negative 3x. 3 times 1 equals 3. Now, we combine all these terms to get our final expression. We can simplify further by combining like terms. We have 2x cubed as the highest power term. For the x squared terms, we have negative 2x squared plus 3x squared, which equals positive x squared. For the x terms, we have 2x minus 3x, which equals negative x. And finally, we have the constant term 3. So our final answer is 2x cubed plus x squared minus x plus 3. To expand this expression, we'll apply the binomial square formula. The binomial square formula states that for any expressions a and b, the square of their sum, a plus b squared, equals a squared plus 2ab plus b squared. In our case, a equals 2x and b equals 6. Let's begin expanding. The squared binomial 2x plus 6 squared equals 2x plus 6 multiplied by 2x plus 6. Next, we distribute the first 2x plus 6 over the second 2x plus 6. This gives us 2x times 2x, which is 4x squared, plus 2x times 6, which is 12x. Then we have 6 times 2x, which is 12x, plus 6 times 6, which is 36. Now we combine like terms. We have 4x squared, plus 12x, plus 12x, plus 36. Since 12x plus 12x equals 24x, our final result is 4x squared plus 24x plus 36. Let's move on to our second example. Here, we have 4 times the quantity x plus 3 squared. We have two approaches to solve this. The first approach is to apply the distributive property and then use the binomial square formula. The second approach is to expand the binomial first and then multiply by 4. Let's use the first approach. We start by writing 4 times the quantity x plus 3 squared as 4 times the quantity x plus 3 multiplied by the quantity x plus 3. Now, let's expand the inner part. The quantity x plus 3 multiplied by the quantity x plus 3 equals x squared plus 6x plus 9. This is from applying our binomial square formula. Finally, we multiply everything by 4. 4 times x squared is 4x squared. 4 times 6x is 24x. And 4 times 9 is 36. So our final result is 4x squared plus 24x plus 36. Interestingly, this is the same result we got from our first example, even though the original expressions looked different. This shows how different algebraic expressions can simplify to the same result. Let's look at one more example to verify the mathematical equivalence we just observed. If we have the expression 4x plus 12 squared, we can factor out a common factor of 4. 4x plus 12 equals 4 times the quantity x plus 3. So 4x plus 12 squared equals 4 times the quantity x plus 3, all squared. But wait, that's not quite right. We need to be careful here. When we factor out 4 from 4x plus 12 and then square the entire expression, we get 4 squared times the quantity x plus 3 squared. So the correct factorization is 4x plus 12 squared equals 16 times the quantity x plus 3 squared. If we expand 16 times the quantity x plus 3 squared, we would get 16 times x squared plus 6x plus 9. That would give us 16x squared plus 96x plus 144, which is different from our previous results. Let's verify this by directly expanding 4x plus 12 squared. Using the binomial square formula, we get 16x squared plus 96x plus 144, which matches our factored expansion. This example shows that factoring before squaring requires careful attention to how the exponent applies to the factored form. In general, when factoring a term with an exponent, the exponent applies to the entire factored expression, including any coefficients factored out. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.